So now that we've talked about the foundations and the fundamentals of NMAP, let's take a dive into how it actually works and look at how it gets the information that it gets. We talked about it. We talked about the fact that you're sending packets to a port, and if you get a certain response back, you know if that port's open or closed. Well, we're gonna take a deep dive into that process and look at how NMAP does everything from discovery all the way through to how it does service identification, and we'll dive into those things. So we're going to start with just basic discovery, which is one of the most common uses for NMAP. How do we check a network or a range of network IP addresses to see if there's something there that we can interact with? And that's where we're going to start. Now, I'm going to kind of follow the process of always starting with the man page, because I want you to kind of get into the habit of, if you don't know something, if you're not sure, ask the man. Go to the man page and look up information about the tool if you're not absolutely sure. If short of that, if you don't find anything on the man page, then you can always go and Google after that. But start with the man page. It keeps you in the environment, and you're being more true to the what the actual author of the tool thinks. So I'm just going to look at man NMAP. We're going to pretend we don't know how to do discovery. So I'm literally going to do a /, and I'm just going to search for discovery. And sure enough, it gives us a few results here. If we look at host discovery, which is what we're trying to do, it actually shows us that we can do a list scan. This simply list targets a scan. And if you practice with that, you'll find it's basically doing a DNS reverse lookup. There's also a ping scan. This sounds a lot like what we want to do. And there's other discovery things that we can do here. But what we're going to do is we're going to start with the ping scan, because this is the most fundamental way to see if there's something out there that you can actually reach. So let's jump into that. And we're going to give it a given network range. Now, in our case, we're going to start with just my network here that we're practicing with. Now, if you don't have a strong background in networking, this might be a little confusing to you, so let me explain what's going on. The reason I did the IP notation like that, because the /24 is a shorthand way of writing 255.255.255.0. That's called the subnet mask. And in the mask, each octet, which are these guys here, represents 8 bits. So if we're using all 3 of these first octets for the mask, that means if each one's 8 bits, 3 times 8 is 24. So a shorter way to write that, because if I gave it this command, NMAP would totally understand that and be able to use that as well. But I'm going to shorten that just by saying /24, and NMAP knows exactly what I mean. Now we're doing a discovery scan, so we're going to do SN and have it ping every IP address in this Class C network to see if we get any responses back. So let's go ahead and enter that. And as you can see, NMAP comes back pretty quickly and tells us that, like, look, we have 1, 2, 3, 4 devices that are up in that given range. So that's how you use it to do basic discovery. Now, past that, where we're going to have to take a really deep dive is looking into the port scan. So let's take devices 4, 9, and 6. If I were to blanketly, we can do one of a few things here. We could run NMAP and put in each one of those IP addresses independently. We could do 4, 9, 6. And NMAP would actually know that we mean to port scan 192.168.248.4, 192.168.248.9, and .6. It understands that. But the problem with taking this approach is, what if it had come back and said there's 200 devices up? Would you want to sit here and manually enter 200 IP addresses? The answer is probably not. So a better way to approach this, and this is why I'm integrating things like output and that type of thing into this, is because you need to really get an understanding of that stuff starting out, because it'll save you a bunch of time. So for example, I'm just going to fire up a new terminal here, and I'm going to do man NMAP again, and I'm going to look for output. Just going to search, and do output. We keep searching for it, search again. And it takes us right to the part in the man page that shows us the different formats that NMAP is capable of outputting things into. We have ON for normal. We have OX for XML, if you wanted to put it out to web form or something like that. We have OS, which is script kiddie format, and then we have OG, which is output grepable. Now, script kiddie format's probably the least useful. It basically takes and does leet speak substitution. For example, your E's will turn into 3's, your A's will turn into ats in your output. It's cute, but it's not very practical or useful. What's very useful though is the OG, or output grepable. So if we take and output our results to a grepable format, then what ends up happening is now we're able to see it in a form that's nicely grepped. Okay, so let's look at that output option. We're going to spend some time just on output here for a bit. Let's look at that output option. If I were to tell NMAP to scan the same range, we're going to do the same discovery scan, but now I'm going to do -OG from the man page, and I'm going to say output to a grepable file. We're going to name it discovery. Well, what ends up happening is now, instead of just having this mess that we see on the screen here, if we look at the discovery file that we told it to create, look at how much nicer the format is. This is a much more concise picture than all of this mess up here. So not only that, we've now followed one of the first important principles of pen testing, which is you're writing your content or your results to a file that you can go back and historically look at. In other words, I don't have to go back and scan again to get this result. I can see it right here. Now, taking this output file that we have here, I'm going to clean it up a little bit. We're just going to do cat discovery. And then I'm going to grep, because it's a grepable file. This is what OG stands for, is output grepable. I'm going to grep for the string up, capital UP. Now, it's important to understand that NMAP, or in this case, Linux, is very case sensitive. So I have to grep for little or big U, little p, because if I did it for just that, just up all lowercase, I get a different result. This result is not useful to me. But if I grep with a capital U, it gives me more of what I want. I've cleaned it up a little bit. And then further, we're going to output this result to another utility called awk. And we're going to tell awk for us to just print field 2. All right, so this is how you say that in awk language. What this is we're saying print for us field 2. We say field 2 with $2. And in this case, if you don't give awk a delimiter or separator, it's going to assume you mean space. Therefore, this would be field 1, and we got a space, which would make this field 2 and a space, and we got field 3 and a space, and field 4 and a space, and field 5. So we want field 2. If we print that, now it gives us just a list of IP addresses. Okay, so with that being the case, we want to now commit that to a file. I want you to notice something. Since this is not an introduction to pen testing, it's, we remember Pen Test Plus, CompTIA expects you to have 3 to 4 years hands-on experience. So we can go into this in a little more depth. Notice here that when we print field 2, we get these IPs out, this list of IPs. We want to now commit that to a file. And I'm just going to call it up devices. Because here's the thing. What if we went out and did this against a real target? Let's take Mississippi State, for example. So I want you to look at the number of IP addresses and devices that come back. There's 109 of these. The reason I'm showing you right out the gate here to learn how to output your files into a proper format is because of the fact that when you're dealing with, for example, 109 devices, it's really not feasible to expect you to sit there on the command line and enter each IP address individually. And if you notice, these IPs aren't sequential. It's not 1 through 109. It's skipping all over the place here. So what we want to do, this is an example of where we would take that output, write it to a file again, right? And then, of course, now that we learned how to use awk and grep, I'm going to grep for this string right here, the capital PTR, because it appears to only exist in these data lines. That's even cleaner. And then I just want field 4. 1, 2, 3, 4 here. So if I go ahead and do that, like we did in the previous one, we get this list of IP addresses that belong to Mississippi State. Now, you want to, again, now that you see the output on the screen, you don't want to commit it to a file until you see that it's what you want it to be, because otherwise you end up with a whole bunch of files of where you were trial and erroring, and you go back and try to do a report at the end, and you spend a whole bunch of time, wasting time actually, trying to decipher which of these files you need and which ones you don't. So don't commit anything to a file until you know that output's going to be exactly what you're looking for. So we know it is. We're going to commit it to a file. We'll call this ms state up. Check it to make sure it's proper. So now if I wanted to scan all these IP addresses, I can now give this list to NMAP, which takes us to another flag now. So we've looked at SN, which is how we do a discovery scan. Now we've looked at OG to output it to a grepable format. Well, how do we take that list now? Let's go back to our original list here. How do we take this list and that list? How do we take this list of IPs and tell NMAP to scan that list without entering each one? Well, if we search, remember I told you always try to go back to the man page first. If I search for input / search for input, it actually tells me right away, look, if you want to give it an input file, just do -il, give it the name of the file that you have your list of hosts in, which a list of IPs counts as a list of hosts, and it'll scan them. So let's check that. So I'm going to do nmap -il, give it my list of hosts, which is up devices. And I'm going to tell it to just scan those and tell me which ports are open on those devices. And sure enough, as you can see, it comes back and does exactly that. It shows me that the .1 device has no ports open. Actually, it has port 53 open. .4 has a bunch of ports open, which is going to automatically make me kind of think this is probably some type of server device, because usually people's desktops don't have 27 ports open. Then we can also see with the .9 device, it's got quite a few ports open as well. Right? So what that tells us is that each of these devices has these ports open. But let's look at a few things. First of all, let's figure out how it's making this determination. This is important to understand. How does it know this? Now, generally, if we see port 80 open, we can assume there's a web server there. Or if we see port 443 open, we know there's a web server there. But how is NMAP proving to us that this port is open? To do that, what we're going to do is we're going to go to the victim side. We're going to take .4 here, and we're going to go look at it from the victim's perspective and run Wireshark so that we can see what that traffic actually looks like. Now, in the other section that deals with sniffing, we go in depth with Wireshark, but I'm going to introduce you to it now because I want you to get comfortable with it. and see that it has many, many uses. And one of the best uses is using it to teach yourself how this stuff works. All right, so as you can see, it's capturing traffic right away there. What we're going to do is I'm going to now create a filter to say only show me traffic related to the .4 device and the machine I'm going to be scanning from here, which is .6. Like so, and apply that filter. And you can see it takes away all the other traffic because there's nothing else there. Now, again, this is not an in-depth discussion of Wireshark, but I'm teaching you to use it as a tool to teach yourself how NMAP actually works. So we're going to scan port 80 on this .4 machine and then come back and examine here what the packet looked like that actually allowed us to do that. So we scan port 80, comes back and tells us that port 80 is open. But again, the question is, how does it know that? All right, let's go look at Wireshark and see what the actual output was. Well, it looks like what happened, .6 right here, which is my Linux machine, sent a TCP packet to .4, which is our victim, and it had the flag SYN set. Now, if you remember your TCP fundamentals, you know that when you send out a SYN, this is you initiating a connection or a handshake. So we're trying to connect to this device. Well, since port 80 is open, the victim .4 responded with a SYN ACK. At that point, NMAP knows that the port is open because if it had been closed, it would have responded with something other than a SYN ACK. So since it knows it's open already, there's no need for NMAP to complete the handshake. Because here's some other things I want you to start thinking about. If it had completed that handshake, then you would have legally connected to something. And there could be a whole lot of legal implications of that, depending on what it is you connected to. So in most jurisdictions in the US and other countries, when it comes to cyber law, connect means you completed the handshake. And notice NMAP is smart enough here to not complete the handshake just to see if a port is open. Right? Now, what we're going to do now is scan port 81, which is closed, and let you see the difference. Because if we change our port to 81, you see that NMAP comes back and says that's closed. Well, how does it know? Well, because NMAP sent a SYN packet again. Notice both times for port 80 and 81, it sent a SYN. But in this case, the victim responded with a reset. And that is what tells NMAP that that port is closed. Therefore, there's no service there. Okay. Now, let's look at something important. The end result here is we've enumerated 2 port states without actually connecting to a device. This scan is called a SYN stealth scan, and we'll dig more into that when we talk about stealthy NMAP scanning. But NMAP tries to do this by default, but that's only the case when you are root. Understand that, only when you're root. Now, the Pen Test Plus is going to expect you to know these things. For example, if we go over and I log into this machine as an account that's not root, so let's log in as Keytron, and I run the exact same command. I want you to look at the command. Exact same command that we ran earlier to port 80. I get the exact same result, but look at how different the traffic is. See how much more traffic was generated there? And it's just because in the first one I was root, and then this scan I wasn't root. So since I'm not root, there's a lot more that's got to happen for NMAP to determine if port 80 is open or not. It did this, sent a SYN. It also went ahead and checked port 443. Got a reset back for that. Then it did a completion here. There's a SYN, ACK, and ACK. So NMAP actually completed the 3-way handshake when you're not root to check to see if that port's open. Now, what the difference here is is if you look at the first one up here where we were root, potentially the difference is something as blanket as the first scan, you don't go to jail because you didn't complete a handshake, you didn't connect. Whereas the second scan where you weren't root, you do go to jail because you did connect. So a huge difference there. And all of it plays on whether or not you're root when you ran the scan. Now we can try to make a non-root user do that send stealth scan. For example, we could do little s big S, but the problem is since we're not root, NMAP is going to tell us you don't have permission to run that scan. Which is why when you're not root, it defaults to the noisier scan, the TCP connect, because it has to do that in order to check the port state. So that's an example of how you teach yourself how these things work. When you look at the options there, the output options, and we will go back to root here. And we'll just go back to man NMAP and look at the output. There's a few more things I want to show you with that. Now notice there's an option here to do output A or OA. What that means is it's going to take the three most common formats here, which is normal, XML, and grepable, OG, and write that to a file. Let me illustrate what that means. Let's make a directory here and just call it output demo. And then we're going to change that directory. So there's nothing in there. Watch this. If I scan the whole network like we did earlier, and I did OA, we'll call it demo of all. What it did is if you look in the directory now, it actually created three different files. It created a grepable version of the output, a normal version of the output, and the XML version of the output. So now if I look at the grepable version, it looks exactly like we expect, nicely grepable. If I look at the XML version, it looks like that because it's meant for, web. And then if I look at the third file, which is the normal version, it looks just like what you would see on the screen, right? So that's another principle that you need to get familiar with, because you may have to be able to recite the fact that if you want to get output in all three formats, you'd have to do an OA. So that's something else that's important to kind of know about the output. But, what I really want to make sure you got thus far is you understand exactly how now NMAP determines basic port state. This is a fundamental thing that's going to allow you to build on that and understand other details about NMAP. I don't really want to go into a whole bunch more flags in this little section, but I wanted you to get this knowledge and understand how NMAP determines port state. When you understand how it does it, you tend to be more confident with it, and you are able to discuss it in more depth when you're trying to explain it to someone else. And that's really how you know that you know it. All right? So that is what I wanted to go over in this section. All right? In the next section, we're going to be doing some more advanced stuff, and we're going to dig into NMAP a little bit more. So stay with me, jump to the next section, and we're going to dig in even deeper. Thanks.